My name is John DeGose, and this is my workshop on Learn Functional Programming with PureScript. I phrase it that way because fundamentally this is a workshop on what it means to functionally program. And that's first and primary consideration is I want to teach you how to be a functional programmer in 2 hours. And if I don't succeed, you get me at the end of class and I will go out and buy you a coffee. I know we have gallons and gallons of coffees here, but we'll walk across the street and I'll buy you a really fancy $4 latte. So you can follow me on Twitter at jdgoes if you like to hear someone ranting about functional programming and PureScript and all things startup life. Today we're going to talk about functions. Actually, we're going to talk about functions a lot. Almost everything I'm going to be talking about today is a function or is related to functions at the very least. But we're also going to dive into some of the terminology specific to sort of the PureScript and Haskell ecosystems, including types, kinds, and also sort of more advanced types of functions. And we'll look at some of the tools you can use as a functional programmer, just some of the real bare bones basics that you're likely to use in any sort of functional programming, and especially in the game that we're going to try to build here at the end. And then, yeah, we're going to have a coffee break because you can never have too much coffee. We'll cover type classes, a really beautiful, elegant abstraction, and effects, which is something unique to PureScript. And then we're going to talk about scary sounding things, because the kind of functional programming that I'm introducing today is known as like hardcore, statically typed, scary, Haskell-like functional programming. And it's filled with all these crazy sounding things that I'm hoping I'm going to show you aren't really so scary after all. It's more their names that are terrifying than anything else. And finally, at the end, I hope we'll have collectively learned enough that we can put that to use, building a simple game and no graphics to distract us. It's just going to be a simple text-oriented role-playing game, but it's going to be a lot of fun. And I've already built the basics out there in the repository, so if you want to download that, you'll be able to get off to a running start. Functional programming, it truly is all about functions. And if you master what a function is and how to use it, you will be able to call yourself a functional programmer. This is what a function looks like. This is the definition of a mathematical function. And this definition is so simple once I explain it and elegant that you'll be amazed that you can build full-featured, rich applications with something as simple as a function. In fact, a function is so simple, it's simpler than the functions that you learn in JavaScript or in Ruby and in all these other programming languages. It's simpler than that. It's so simple. I actually teach functional programming to my 6-year-old daughter, and I would never dare try to teach her JavaScript programming because that stuff is hardcore, difficult to understand. So a function is a mapping from one set called the domain to another set called the codomain. And in programming languages, we like to name all these things just so we can talk about them, and we do that in math too. And in this particular case, I've named this function John, because it's a model of my dietary preferences. I've named the domain food, and I've named the codomain happiness. And the function John maps from an element in food to an element in happiness. So in the case of eggs, it maps it to unhappy because I absolutely hate eggs. I can detect them in mayonnaise. I will not eat eggs under any circumstances. And coffee, I love coffee, so it maps that to a happy face. This concept right here, as simple and beguiling as it is at the heart of functional programming. And if you're thinking to yourself, that's too simple, it needs to be harder, functional programming is supposed to be harder than that, it's actually not. And the reason why functional programming has addicted some of us and we refuse to write in the old style is because it brings a refreshing clarity of mind to understanding what a program does. If you master this concept here, then you will have mastered what it means to be a functional programmer. Now these sets on the left hand and the right hand are not always as simple as food and happiness. And we're going to go through some more advanced sets that can be tricky to understand. But fundamentally, every time you're struggling with some concept in this workshop, I want you to go back to this and say, this is what a function is. A function is a mapping from one set called the domain to another set called the codomain. So this is very sort of abstract and mathematical, and it's how I teach my daughter about functions. What does it look like when we translate that to PureScript, to a programming language like PureScript? Are we going to have arrows? Are we going to have named sets of things? It actually turns out that in PureScript, a function looks a lot like it looks up here. Now this is how we define a function, and if you have your laptops open, please type this in or type something simpler in just so you can get a feel for how you define these things. In this example, the function John I've defined below, and you can see that it's a mapping. You can even see that arrow in there. It's a mapping from the set of elements called food to the set of elements called happiness. That is, with every element in food, it maps that element to an element in happiness.
Sorry.
Go ahead.
There was a REPL. I just did all the downloads, but
PSCI
PSCI, okay.
is the REPL for PureScript if you want to type stuff into there.
Thank you.
Yeah. So I define the function right beneath that, and I say John of eggs is equal to unhappy, and John of coffee is equal to happy. So I'm defining this function piecewise. I'm defining it one element of its domain at a time. Look up there. PureScript allows you to define these things called sets. So in PureScript, I can define a set called food. And that set of food consists of two elements. One is called eggs, and the other is called coffee. And that pipe operator, you could read it one of two ways. You could read it as an operator that forms a set out of a number of individual things. So I'm building up a set of my things. Or you could read it as sort of or, a food is either an egg or coffee. And happiness is either happy or neutral or unhappy. But either way you read them, they're essentially the same. I'm building sets here. I'm giving them names because this is PureScript and I like to give things names in programming languages. I built a set called food that consists of the elements eggs and coffee, and a set called happiness that consists of the elements happy, neutral, and unhappy. And then I built a function, and I'm telling PureScript this function is a function from the domain food to the codomain happiness. So go back here and look at this. That simple function translates into PureScript like that. And every single function that you look at is going to be some variation on that same very simple, straightforward theme of what's my domain of the function and what's my codomain, and how am I going to relate the elements in the domain to the elements in the codomain. And how I phrase it to my 6-year-old daughter is, you feed this function called John an element in the domain, and it will spit out something in the codomain. You feed it eggs, it will spit out unhappy. You feed it coffee, it will spit out happy. So that's how you define a function. How you use it, how you call it, as you would say in other programming languages. Sometimes we don't say call functions when we're dealing with functional programming languages. Sometimes we say apply them. And we apply them at elements in the domain. So we can take that function John that I define, and I apply it by actually using white space, which may seem sort of like a funky way to apply a function. But we use white space, and we say John space eggs, and I feed it an element in the domain, and it spits out an element in the codomain, namely unhappy. And same way for John coffee, John space coffee. I'm applying the function John to the element in its domain called coffee. And what do I get out? I get out happy. So notice how, sort of to define it, I used a little bit of white space. To apply it, I used a little bit of white space. There's that element of symmetry here. And that's one of the things you'll notice about PureScript and Haskell is there's a great deal of symmetry to these languages and consistency, which makes them simpler to understand and to pick up. So there are two important things about every single function. These are math properties more than they are programming properties, unfortunately. But they're the properties of totality and determinism. And these two properties here are what makes reasoning about functional programming so elegant and so
so easy and what addicts people like me to functional programming. I'm addicted to functional programming, not because I think it's complex and uses ugly sounding words and names for things. I'm addicted to functional programming because it makes my job as a programmer that much easier. I have less to reason about because of these two laws. The first one, totality, says that every element in the domain must be mapped to some element in the codomain. A function is total. A real mathematical function is total. And the second property is determinism. So applying a function with the same value in the domain results in the same value in the codomain. In other words, let's go back to this function. If I apply John to eggs, I am always going to get back on happy. I can do that 1,000 times a day, 1,000,000 times a day, and it doesn't matter. I'm always going to get back on happy. And that's because this is a real function, it's deterministic. And that is a property of pure functional programming languages, is everything is a function, everything is deterministic. You apply a function at a value, and it doesn't matter how often you do it, you always get back the same value in the code. And that's the property that makes reasoning about these functions so much simpler. Because if you take JavaScript, for example, if you call a function in JavaScript, you may get back different answers every time you call it. And that means you have a lot of stuff you have to keep track in your head if you want to understand what that function is going to return. Because you basically have to simulate the state of the program. You basically have to perform these mental calculations in your brain, updating variables, doing this and that, and your functions are returning different things all the time. It makes it harder to reason about the correctness of your program and understand what it is that you're doing. But in a pure functional programming language like PureScript, you have the guarantee that every time you call a function, you're going to get back the same value. It's deterministic. So let's break and do a few exercises. First off, I want you to notice these two functions here, and I've given them names, and I've told you what sets they map from and what sets they map to. So the first function is called superpower. It maps from a set called character class to a function to a set called superpower. The second one is weakness. It maps from the domain of superpower to the codomain of kryptonite. So what we're going to do is build these two functions. We're going to do that by building the sets representing the domains and codomains, and then we're going to define the functions. And it doesn't need to be super fancy or anything, but go ahead and create a set called character class, which is going to represent different types of characters. And that can be literally anything you want. It could be, flying person, or like, I don't know, wall-walking person, if you want to think of Spider-Man. And then map that to another set called superpower that's going to represent a set of superpowers. So if you've all sort of got that, let me switch over to the text editor and show you how it is. So this is how we define that set. Called character class. And you can define it in any way you want. I'm giving this two elements. And it's going to be a flying character, or it's going to be a wall-walking one. We're going to say, we're going to define superpower. This will be a different set. And we'll say the superpower is either laser beam eyes or stickiness. And I'm going to define a function called superpower. That's going to map from character class to superpower. I'm going to say that flying goes to laser beam eyes. And say that stickiness goes to wall walking. A wall walking character has the superpower of stickiness. And then I'm going to align my equal signs because I'm obsessed with the pulse. Okay. So now I have to create this function called weakness, which is going to map from superpower to a new set called kryptonite. So let me define a new set here called kryptonite.
Should this be working in the REPL?
Yeah, this should work in the REPL, except the multi-line thing is weird. So you're going to have to use let if you use the REPL, because you have to introduce all these things with let.
Is there anything funny you have to do to a pipe function?
No, you should just be able to call the function name space and then the element in the domain.
In the try PureScript, by the way?
Yeah, you can copy and paste this whole thing in there. Try PureScript.org doesn't remember your previous settings. So you're going to have to copy and paste the whole thing in there.
Is there a dividing keyboard in PureScript?
Unfortunately not. No. Soon, no. All requests are welcome.
So in the REPL, how would you transform line 7? So that, because I get an error with that. So where do you need the?
Well, it doesn't want a type signature. Is there a way to specify a type signature, Phil? In the REPL? Let? And multi-line? You need the multi-line mode and to use the let, introduce it to the let. So we're going to say kryptonite will either be literally kryptonite, or what should Spider-Man's weakness be? Does he have a weakness?
Mary Jane.
Guns, Mary Jane, Mary Jane, definitely. Okay, and we're going to define this.
What do we say for day night Mary Jane?
What's that?
What is it?
So we're saying metaphorically.
Oh, okay.
So it's just got a weakness. And we're going to say that kryptonite is a function that maps from. Actually, I did superpower. I think I did superpower in the exercise. Kryptonite. So we're going to map the superpower of laser beam eyes to the kryptonite of literal kryptonite. And we're going to map the superpower of Mary Jane. Oops. The superpower of stickiness to the kryptonite of Mary Jane. And there's our definition of the 2 lines. Yeah, go ahead.
How long won't it get confused with data being kryptonite and then having itself for Mary Jane?
It actually won't get confused with that, and the reason is they only occur in specific positions in your PureScript program, and I'll talk about this in a second. That's a really excellent question, by the way. The question was, I'm using kryptonite to describe this set of things called kryptonite, but I'm also using the word kryptonite to represent one of the elements in that set. And PureScript doesn't get confused by that, and Haskell doesn't get confused by that. This entire family of languages don't get confused by that. They're separate namespaces entirely, and that's because they only occur at certain positions in the code. Like this one only occurs after these lines here, which you can read, has type. And that's where this one occurs. And this one here only occurs in value position in the language, so no confusion. Yeah?
What's the semantic importance of data? Like declaring it as data, why is that?
So that's just the way you introduce a set in PureScript. Data says I'm introducing some element of data. I'm forming a set here that's going to contain a bunch of things. So I can map from that set to another set. Gotcha. The data is a keyword that, it's sort of a weird keyword, but it is what it is.
mean type?
What's that?
Does set mean or not mean type?
Yes, it means type. I'm about to jump into that. Okay, types. So let's jump right in here. I sort of showed you what it's like to define a function, but there's like lots of hazy stuff around the edges, which is why you're all giving me these really excellent questions. Fundamentally, PureScript is a statically typed programming language. That means that we're going to spend a lot of time in this workshop looking at types and dealing with types. What is a type? Well, fundamentally, a type is nothing more than a set of values. So a type is a name that we give to a set of values. So just like I invented a set called happiness, and that consisted of 3 elements, happy, neutral, or unhappy. Happiness is a type in PureScript. It's a set in sort of the math world, but in computer programming languages, the notion of set transfers over into the notion of a set. And so we talk about sets of elements, and these sets of elements have names, which are the names of the types. So we're going to spend some time looking at a bunch of different types. PureScript has simple basic types. It also has some more advanced types. And we're going to look at each one. Sure. So the set of literal types, there are currently 3 sort of built-in types in PureScript. And these are going to be very familiar to you from other programming languages. There's the set that we call string, that is the type string. And that's a set that contains all strings like foo and bar and so on and so forth. And then there's the set called number, which in theory contains all numbers, and in practice you have to deal with the floating point monstrosity that is JavaScript's number. And then there's Boolean, which is the set that contains the values true and false. So all these are sets, and I want you to go back in your mind to that picture, that big old bubble, and I want you to picture a bubble here that contains lots of different things. And in the case of string, it contains an infinite many things. But you don't need to worry about that. It doesn't really affect the visualization all that much. Just think of them as being infinitely many points in that bubble. Number consists of finitely many things because we're limited in how many bits we can store one of these things. And then Boolean just has 2 things in it, true and false. So that's pretty boring. Let's go on to a more interesting type that's going to allow us to define more interesting data structures for the game that we're building. And this is called a product type. I sort of sneaked this in to the last lesson without properly introducing it. But now I want to properly introduce this. This is called a product type. And basically what it consists of is a set called loc. The data keyword introduces one of these product types, and sort of the word immediately following that, it has to start with a capital uppercase letter, just for historical reasons, really. And that's the name of the set that you're defining. It's the name of the type. And then immediately following that is this thing called a constructor. It is actually the name of a function that will create values of that type. And this is why you can have something like data kryptonite equals kryptonite or Mary Jane. It's because that second reference to kryptonite is a function, while the first one is a reference to a type. In this particular case, I'm defining a location, and the context is we're going to build a game. Let's give our character a location on a map. And he's going to have a location, and we're going to describe him by 2 numbers. So like sort of, X and Y coordinates on some sort of map so we can track where our character is going to be, what he's doing. And so we're going to define a set called location, and we're going to define a constructor function called location. It's going to take 2 parameters, and those parameters are going to be types. So what we're saying by this is a location consists of all things that are a location consist of 2 numbers, the x coordinate and the y coordinate. The first location is this name of the set we're defining. The second location is the name of a function that will create values in the set if you provide it with 2 numbers. Does that make sense? So how do we actually create one of these? Well, we just use the name of the function, and then we supply the 2 parameters using white space to apply the function. Yeah?
So can I say like data point equals point number or polar number?
You can.
Oh, okay.
You can. Okay, so that's how you define one of these things. And now, where am I is an element in the set location. And so in any function, you can use, in any function that maps from location to something else, you can feed that function, where am I, because where am I is an element of the set called location. So go back to that visual illustration at the beginning, and you can sort of, see that emerging from what I'm talking about now. Okay, so you can construct this thing, you can construct values of type lock with the lock function, just by supplying the two parameters it requires. The natural sort of opposite of construction is deconstruction. That is, if I have a lock, how do I extract out its first position and its second position so I know where that character is? Because once I build a lock, like, it's not obvious. How are we going to get out the two numbers we fed into that location constructor function so we can tell where that character is on the map? Well, you do that using deconstruction, which is otherwise known as pattern matching, a feature that functional programming languages are very famous for. And the pattern matching, it's basically just pure syntax. It looks like what you see up there on the slide. I define my function called lockx, and lockx is going to pull out the first number, the first part of a location data structure, the x coordinate of where that character is on the map. And it does that by using that syntax there, and what it's saying is, if you pretend that lockx underscore is creating a value, it's saying, I want you to give the names x and underscore to those positions inside the constructor function, so that on the other side of the equal, I can refer to things inside those locations. Does that make sense? And again, if I want the lock y, what I can do is I can use the pattern matching syntax to extract out the second element of that and call it y. This creates a new variable called y. And I can refer to that. There's a typo on that slide. That should be equals y. The second block y should be equals y, not number. And then I can call these functions, which I'll call just extractor functions, because they extract out pieces of information from elements inside the lock set. I can call them on those two values, as I've done there. Lock 1, 2, I call lock x on the value lock 1, 2, and I get back 1. And I call lock y on the value lock 1, 2, and I get back 2. So I'm able to extract out, through pattern matching, whatever I build using this product type, whatever I build, no matter how complicated it is, no matter how many different types it accepts, I can always extract that out using any component I want with pattern matching. And the components I don't care about, I can just call them underscore, which basically means ignore it and don't create a variable name for that specific piece of information inside that data type. Does that make sense? Yeah.
You might cover this later, but is there a specific name that we would typically use for, in this case, the X or Y? Do we call those fields, or in PureScript, what would that term be?
Well, that's a good question. I actually don't know. Elements of the product, I guess, works. Yeah, PureScript has a different connotation for the term field, that we'll see in a second. So you probably wouldn't call them field. Well, they are like fields. It's like you have one field, it's like a name, it's like an anonymous position field. That's a good question. I actually don't know what they're called. Okay, so here's another way that you can use to deconstruct these things. And it's basically just pattern matching. It's just a different way of doing the same thing. And in fact, all the examples of this, PureScript compiles down to something that looks like this, and that it handles this case. But it's just this syntax. You've probably seen switch in some programming language that you use, or match, or something like that. It allows you to switch between a lot of alternatives. And there's a similarity between that construct in whatever language you use and pattern matching. So that's sort of where the syntax comes from, but you just do case, and then you specify the value, then the keyword of, and then you match the patterns down below. And for every pattern, you have that arrow symbol, and you produce a value that you presumably extract from the data element you're deconstructing them.
So I thought locx was the function. It looks like we're using it as a type. Locxl.
So yeah, loc is, there's actually two namespaces here. Loc is a type, that is, it's a set of locations, the type name. But it's also, I've used it for the name of the constructor. So it creates a type called loc, and it also creates a constructor name called loc. And that constructor name called loc allows us to create elements of the type called loc. So think of loc as being this big old set that contains these things that all have two numbers. And loc is a function that allows me to create one of those things inside that set. But it's also the name of the big set. Is that a little confusing? Yeah, quite possibly. And it usually,
It was locxl, not loc. On the slide you were just on. You said locxl equals law.
oh yeah, so here I am giving a name to the first slot inside that data type. There are two slots inside loc to hold the x and y. And I'm saying case L of, and then I say loc, and I'm giving a name to that slot, and I can refer to that x after the arrow. I'm creating what's called a variable binding here. I'm creating a variable called x that's going to attach itself, if you will, to that slot, that first slot of the location data structure. Does that make sense?
Yeah, I think.
Yeah. Okay, so this is quite a lot to digest. And fundamentally, we're not doing anything but creating sets, but sort of the complexity of the sets that we're creating has grown, because now we're not just creating simple things like Mary Jane and kryptonite, but we're creating sets that contain pairs of numbers. In the case of loc, we're creating actually sets, a set called loc that contains these pairs of numbers. And with that complexity comes an excellent time to stop for a little break and do some exercises. So let's create a character stats product type that's going to model some character statistics in the role-playing game. So we'll have health and strength and whatever else you want to put in yours. Go ahead and stuff it in there as a product type. And then we're going to create some values of that type to understand how to use the data constructors. And then finally, I'm going to show you how to use pattern matching again to make that more concrete to extract out components of that data type.
Can I just ask a few questions about the mechanics? So sorry, I've been putting this stuff into a file and I wanted to load it into the REPL. I see there's a load, but it complains, I guess, that things aren't in a module. If I put things in a module, then they seem to be namespaced funny. So I'm just wondering what's the best way to, if this stuff is in a file, load it to the REPL stuff.
I think load is the best way, but you'll have to put it in a module. And then unfortunately, you're going to have to learn about the import keyword,
Okay.
which I didn't even want to talk about, but import m allows you to import a module, the things inside a module called m. So if you define a module called module m where, and then you list a bunch of code here, then you can load that in, and then you can import m, and then you'll get all the junk that you defined inside it.
So if we're, prior to this, you were just typing PureScript into a file. If we want to say, okay, now we want to test this and make sure it's right, what's the best way to do that?
I usually compile it. I'm not a fan of REPL, so I'm probably the wrong person to ask.
Okay,
So I usually just compile.
compiling, just PSC and then file name?
PSC and then file name.
So when I did that, it complained it wasn't in a module.
Oh, right,
Exactly
yeah,
as
so
written.
that's exactly right. You're gonna have to, if you want to put this in a standalone file, you will have to put it in a module. So let me do that from now on. And then inside PSCI, do something like load first, whatever, import m, and then I'd start playing with all this stuff. Okay, so character stats. I'm going to create a product data type. This is a set called character stats. And again, confusingly, I'm going to call the name of the constructor function character stats, which you really will get used to. There's some things like syntax in PureScript and other languages like it that you just have to sort of get used to over time. And I'm going to give this, let's see, a name. So I'm going to choose the literal type string. I don't want the name to be a string of characters. I'm going to give it a health, and maybe I'll give it a speed. And now I'm going to create a few examples of a few elements in this set by using the constructor name called character stats. So remember, this defines a type. So I'm going to say test1 here. It's going to be a test of this type. It's going to have type character stats. That is, test1 is an element of the set character stats. And then I'm going to say the name of this character is Mary Jane, and her health is 100 and her speed is 200.
Question.
Yeah.
I don't think there is, but since you, for the type signatures, is there a way to say all of these, the proper elements have the same type signature? So I can say test1, character stats, character stats.
No, they do not. So you have to annotate that. And PureScript is actually, I don't want to go into that quite yet, but PureScript is smart enough to be able to tell that from the context. So you don't actually need to say that test2 is an element of the set character stats. It's going to cover that. But for documentation and just to get you used to writing these things, I think it's good to have. So I've here created two examples, two elements of the set character stats. And I've done that by using the constructor function called character stats, which takes three things, namely the name and the health and the speed, and gives me an element of that set. So now I have test1 and test2, which are both elements of the character stats set. Go ahead, you have a question? Yeah. Oh. Alrighty, so we've constructed these things, but now that we've constructed elements in the set character stats, how are we going to extract out some stuff? Well, we're going to do that using pattern match. I'm going to define a function called nameOf, which is going to go from the set character stats to the set string. So it's going to take something in character stats, and the name I know I'm storing in the first element, so I'm going to list that first element here. I don't care about the second element of the product, and I don't care about the third element of the product, so I'm going to just use an underscore there. Don't need to get those names. And then over here on the right-hand side of the function, I'm going to refer to the variables I introduced, namely name, and I'm just going to return it.
Is indentation significant here?
Yes. PureScript is a white space sensitive language, so indentation is important. So now I'm going to call nameOf on test1, and I'm going to get back Mary Jane. This is the other way of running PureScript, by the way, inside your head.
So those last few lines aren't really code, you're just saying that's what you get.
That's right. Okay. Exactly, and you can test that out in the REPL if you want. Okay, so I've constructed elements of a new set called character stats, and I've extracted out elements of that, and you can sort of see how it works for the rest. So we're going to move on because we have a few more, ever more interesting types to explore before we get to the heavy-duty stuff.
What's the comment character?
Comment character in PureScript is dash dash. That's a single line comment.
Okay.
A multi-line comment is left curly dash, and then your comment followed by dash right curly.
Okay.
So, coproduct types. So, this allows us to create even more rich types of sets that we could base our functions on. A coproduct type, we've already seen that actually. We've seen that in almost the very first slide. My definition of food and happiness We're both using sort of product and co-product types. And it's the pipe operator. The pipe operator is used to create a co-product. And in this particular case, I'm creating a set called NPC that's either going to be one thing or another. It's either going to be an ogre, it's a non-player character. It's going to be an ogre who has a name and a location and maybe a health, or it's going to be a wolf who also has a name and a location and health. And every NPC is either going to be an ogre or a wolf, just like every food item, my initial example, was either going to be eggs or coffee. And every happiness was either going to be happy, neutral, or unhappy. So that's the name of the type that I'm creating. And in this case, I'm not going to use that name as the name of any of my data constructors. Because I want to introduce two data constructors, because this is a co-product type, so an NPC can either be an ogre, or it could be a wolf. It can't be both. It's one or the other. So I'm going to use the names ogre and wolf as the name of my two data constructors. So I'm introducing here two data constructors, each one of which will give me an element in the set NPC. So I use the ogre data constructor to give me an element in the NPC set that happens to be an ogre, and the wolf data constructor to get an element in the NPC set that happens to be a wolf.
Could you also just create ogre and wolf as types and then have data NPC equals ogre or wolf?
No, unfortunately that requires a different type system. But there are some programming languages that allow you to do that. And these are the constructor parameters, just like you saw with the product. When I call the wolf function to get myself an NPC, I'm going to have to supply three parameters: its name, its location, and its number, to get an NPC.
Do all constructors under NPC have to have the same?
No, that's just sort of coincidence in this case. But for example, maybe there's a big bad monster who doesn't need a name in my game, or who doesn't have a name, and I just call the constructor big bad, and that's it. Or God doesn't have a location, so just put him in there like, God or ogre or wolf. Okay, so that's how I construct an ogre or a wolf. But once I have an NPC, that is, once I have an element in the NPC set, how do I figure out what it is? Because it could be one of two things, right? And further, like I might want to extract out one element of one type, or of one branch, or a different element of a different branch. The possibilities are endless, and I do that using pattern matching again. I'm pattern matching against the names of the data constructors. So because I have two data constructors here, I create a function called nameOf that's going to extract out the name from an ogre or a wolf, because they both happen to have a name. So similar syntax in this syntax bit, there's no easy way around it. You just have to sort of memorize it. But do keep in mind that the syntax for the pattern matching is the same as the syntax for the construction. So there's that symmetry there. So whatever syntax you use to specify the data constructor is followed by all that junk. You use over here, specify the data constructor name followed by all that junk, and you give names to those slots inside the project. And keep in mind, this is an example of something that is either this or this, so it's a co-product, but it's also a name and a location and a number. So each one of these are individually products. And of course, you can use this funky case NPC of expression type thing, your switch, if you will, to also do pattern matching. They're both equivalent ways to do the same thing, and you'll see both styles in PureScript code bases. Okay, we are ready to create some monsters here. Because now we know we have some type, and we can create different types of monsters. When we just do product types, we were basically limited to one type of monster. But now we have this wonderful thing called some type. So we're going to create different types of monsters, and we're going to make sure they share at least one common piece of information. It could be whatever you want. And we're going to create a few monsters of these different types of monsters. And then we're going to create a function that's going to extract that, whatever it was we made common in all these different classes of monsters. we're going to create a function to extract that out. So let's go ahead and jump over here. And define a function called monster. It's going to be either a werewolf with a name, and we'll give them a health. Oops. Or it's going to be a vampire. And we'll say that vampires don't have a very good. And then I'll create a function called extract name. So it's going to map from the monster set to the string set. You give the monster, it's going to spit out, namely the name of it. Oops.
I feel like this question was asked before, but I'm not totally clear on the answer. So right now, monster is a type, and we have a type constructor called werewolf that takes a string and number. But could we also define a type called werewolf, whose type constructor was werewolf with a string and a number, and then say data monster equals werewolf or vampire string? Or just to clarify.
Okay, I see what you're saying. Here's what we could do in this case. We could create a set called werewolf.
Right.
And maybe that werewolf accepts a string and a number. You have to provide that to construct it.
Yeah.
And the set called vampire, and a data constructor called vampire. So you just call vampire to construct it, and you just have to supply a name for vampire.
Right.
And then down here, we could do werewolf, but again, remember, this is where we're going to run into some difficulty. I'll call this make werewolf. And I'll call this make vampire. And you can sort of see the problem because I've already introduced a function called werewolf. So I'm going to have to call one of these make werewolf, or werewolf 2 or something.
I see.
And fundamentally, like you might do this when you're beginning, just because I understand. I used to do this myself, but eventually you sort of learn to embrace the idiomatic way of doing it, which cuts down on pattern matching and doesn't really decrease your typeset. But this is sort of the way you would do this in an object-oriented programming, which is why I used to do this. I'd always factor these things out, and my constructor parameters would always take one element of unique type. But you end up giving up that habit just because it's causing a lot of
Thanks.
Yeah.
So in your original example, you're not declaring a type on the right-hand side of the equal sign.
That's correct. Yes, these are functions. There's only one type here, and that is monster.
Okay.
There's only one type, and there are two ways to create that, using the werewolf data constructor or the vampire data constructor. Okay, and
I got an error when I tried to build that, it talked about an orphan type.
when you try to build this here,
Yeah. Orphan type declaration for extract.
yeah, if you need to be in multi-line mode if you're entering that through the REPL.
No, it's not the REPL, I just did a compile file.
Usually it will do that if this is not the same as this. So what it's saying, that orphan type declaration means you declared a type, but you didn't supply a function to implement it.
Oh, yeah.
So maybe there's a typo.
There, yeah, it's a typo. Thanks.
Yep.
So you said it was able to infer that variable, not variable, that identifier declaration. Can it infer the function declaration as well?
Now, it can only infer the type declaration. And it infers it because you can sort of infer it yourself. If I deleted this line here and I said, tell me what set Dracula is an element of, you look at this vampire here, and you go up and say, oh, vampire is a data constructor for the set called monster. Okay, so that's it. And
the unique number for the variable constructor?
Yes, that's correct. Oh, yes. We'll give them it'll help out 10,000. Okay. So we'll briefly cover one more thing and then we're going to take a break and jump back into this. Record types. And if you're familiar with records in JavaScript, then you're going to be right at home. These are similar to structs in sort of C or C++, and similar to classes in object-oriented programming language. So you're probably going to have seen them before, and PureScript's notion of records are actually matched with more with what a record is in those other programming languages than Haskell's notion of records, which are really totally fake records. And these records, PureScript compiles to JavaScript. These records actually map into JavaScript objects, which makes it very easy to do the interop between JavaScript code and PureScript code. So here's how you introduce them. The record type is technically everything, including the curly braces. And what you do in that record type is you define a row of types. And you don't have to remember that, you're probably going to forget it, you don't even need to know it. But technically everything right inside the parentheses, but before you get to the individual fields of the record, is called a row of types. And then you define pairs of things that look like this. The pairs of things have a label, which is the name of that field. And that's great, because up until now, all our slots inside these data constructors have been anonymous. And if I define like number and number in a row, what's the first number? It could be health, or it could be stamina or something. The second number could be who knows what, right? So what records allow you to do is have that same notion of a product. That is, you have all these different components, you have to supply them all when you construct one. But they allow you to name the individual components of that product. And so here, you give a label to each one of these and the type of the label. So we say that name is an element of the set string, and lock is an element of the set scope, and health is an element of the set number. And suddenly we can refer to all these things by names. You construct them just using the curly brace notation. And let me update this example. Let me actually show you that here. So let's say I want to give this, actually let me just modify this. I'll give this werewolf a name, and now I'll give this a label so it actually knows what it refers to. And I can construct these things. The syntax for construction is going to be almost certainly exactly what you expect it to be if you're a JavaScript programmer. That is, I use sort of JSON notation here. And I'm constructing a value, happens to be a record. With these two elements in it. And that's how you do it. And it allows you to clean up code because you're suddenly able to give names to all different components of your product types. So actually a lot of people prefer to use records in a language like PureScript rather than products just because it's clear what's actually going on once you can give those individual slots names. Yeah.
Yeah, I was going to ask, so how does one decide, or what are the advantages or the reasons why one might use a product rather than a record?
So it mostly comes down to personal preference, but there is an advantage to using a product, and I'll talk about that in the next section a bit when it comes to partial application. You don't actually have to supply all the parameters to your data constructor at once. You can supply them sort of incrementally, feed them into it. If you're familiar with query functions, that's what's going on here. That's really the only advantage, and actually you can achieve something similar using records.
Is generated JavaScript significantly different for
This will generate, oh yeah, the product, that's actually a good reason to use records, because a product will generate some ugly looking JavaScript. And a record will generate pretty looking JavaScript that other people can use. So that's a reason to use records rather than products. Okay, so there's one more thing I want to show you just real quick, and then we'll stop for a break, and that is, okay, I can construct one of these things, but what's the syntax that I use to extract out the elements once I have a record? And that's pretty straightforward and follows probably what you expect. Oops, shoot. So what I'm saying here is, oops, I need parentheses, and then this will compile. The parentheses here, what I'm saying is, just like I created Dracula by building a record using this syntax and using the data constructor vampire, if I want to look for, see if a given monster is a vampire, and then I use this pattern match and specify the name of the data constructor here, and also a record, the names here to the left of the colon operator have to be names inside the record. They have to exist inside the record. And then the names to the right are the things that you create. So you're extracting out the name and you're giving it the name n. You can refer to n on the right-hand side of the equal sign. You're creating a binding for that variable. Yes?
Does it then also enforce that when you have like the declaration of that constructor that it has to have a name or a throw in there? Like we have to pass a name.
If you try to delete this, you mean?
No, I mean up above, like we're declaring the data monster and your different types.
Yes, if I tried to delete this, it would complain.
Or, I mean, what I meant is like if you try to make a new werewolf without a name in the record.
Oh yes, yes, that's exactly right. So down here, if I try to create a big bad and I forget to give him a name, then that's going to complain. Why? Because there's a discrepancy between the werewolf data constructor accepts a record that has a name and a health, and I've only provided it with a record that has a health. So the compiler is going to say, you're trying to feed that function something that's not in its domain. You've declared the domain to be the records that look like that, and you're feeding it something that's not in. Yes?
So it seems like when you define these extractor functions that they kind of, it looks like a lot of repetitive typing.
It is.
Is there anything at all that can kind of reduce the repetition there while using constructors?
No, not really. However, there is for a record. For the special case of a record, there is a way to do that. And actually, that's the topic of the next section. I'll show you. It's actually using the JavaScript dot operator. So if you have a record, then you can use .name to extract out the name, or .health to extract out the health, if you have a reference to a record. But pattern matching is how I did it here, just to teach you how to use that syntax. Yeah.
Will the name work on, you don't specify whether it is a vampire or werewolf?
It has to be either a vampire or a werewolf. So if you just try to use, like, first off, I have to.
If you write just the name of lowercase monster and it goes monster, the name will work for this.
You mean something like r.name?
Yeah.
I think so.
Because it's a different name. It's a funny name.
Oh, actually, that would not work. You're right. You're right. That would not work. Yeah, because there's no way of knowing. You basically have to prove to the compiler that there is a name for each of these cases in order to make that construct.
Can you have another constructor werewolf that just took help?
Theoretically, if we had constraints, is that right, Phil? We'd be able to.
So I think you can say something like the name of werewolf law, and then you can extract it out of RW.
I was just trying to figure out what sort of type system or feature of the type system would allow us to write something like name of r equals r.name.
So that will compile, but it won't work against werewolf.
Oh, right. Yeah, that's correct. Yeah, because it is. So you could write a name of, but here's the issue. If I try to do name of, you actually can write this. But if I try to do name of then what I'm passing to this is like the actual type of this. I'm going away. Actually, let's just declare break right now. Okay, we're going to jump right back into it. And what I'm going to show you now is a little bit of syntax for working with record types. So the first thing I want to show you is the dot operator, and if you know JavaScript, you already know the dot operator. If you have a record in PureScript, you can extract out different fields by using the dot operator. So here, I pattern match against my NPC, and my NPC is going to be an ogre or a wolf, and I'm going to call the value that I supplied to those data constructors, I'm going to call it record, and I'm going to extract out the name field of record in both cases by doing record.name. So the dot operator, if you have a record, the dot operator allows you to drill down into that record and extract out a name field. PureScript also has some magical looking syntax for updating records. Now, I put update in quotes because PureScript is a pure functional programming language, which means that when you call a function with a given value, it's going to deterministically return the same value in its code update every single time you call it with that value. And what that means is you can't actually, if you have a record, you can't actually go into it and change its value, because to do that would violate determinism. It would violate determinism because you could embed that function in another function and end up mutating stuff and returning different values every time you call it. So this version of updating records actually means to create a copy with a certain modification applied. So in this particular case, I want to change the name of any NPC. So I match against the two cases, ogre and wolf, and if it's an ogre, I'm going to construct a new ogre by taking that record and updating the name field to each record. And the syntax is literally your reference to the record, space, and then you put the fields you want to update in curly braces if you give them new values. So everything from ogre onward, record name equals Shrek, is a record update syntax. It says take the record called record, in this case, and take create a copy of it with the name changed to Shrek. So this returns to a new record. It's completely identical to the old record, except for one change, and that is the name field has been changed to Shrek. And same way for the second case down there, I take that record, it's a wolf, and I construct a new record with the name changed to Big Bad, and then I construct an NPC by feeding it to the wolf data constructor. So I'm deconstructing on the pattern matching side of the fence, and I'm reconstructing on the definition side of the fence, the definition of that function. I'm saying change the name of an ogre to an ogre. I could have easily done it, like change an ogre to be a wolf and a wolf to be an ogre, and all kinds of other changes as well. And finally, I don't want to get too much into depth right here, but you're going to see these weird looking underscores when you look at PureScript code. And I don't even want to talk too much about what they do, but basically they're shorthand ways for creating functions to either update a given field or update a given record, or even update both a record and a field at the same time. And so when you see one of these underscore things, in the definition, just make a mental note to yourself, go look on like the PureScript wiki or the PureScript book, or figure out what that syntax means. And it's actually pretty straightforward, but I don't have time to dig into it now. So now what we're going to do is rework some of these examples, because the early examples that we've created, if you've been following along, have not used records, and it's been sort of hard to tell, okay, what's that slot number 2? We didn't have a name to give that slot number 2 by. So now we have record types, and we can create records, and you can update records, we have a means to more sophisticatedly describe these data types to names all the different fields. And we're going to do that in particular with a class called inventory item. And let me walk you through this exercise. Basically, it's just create a constructor that takes a single record, and that record will have fields relevant to inventory items that a player character or a non-player character might carry around with him or her inside a game one. So, that's the type. That's not the name of my set. And the name of my data constructor is going to be, but just to show you that these things really can be different, they're totally independent of this kind. What the heck, I'll call this an invite. So the constructor is called invite, but the set of values is called inventory item. And what should the inventory item have? Well, we could give it a name, right? What else should we give it inventory item? Maybe a weight. Maybe we add up the weights and it slows our character down. Maybe how many slots it takes up. If our character can only hold the equivalent of 20 slots, then maybe some inventory items take up 1 and some take up 10. Okay, so let me parse this apart for you. This is a set called inventory item. This is a constructor called invitem that takes something that has this type. What is this type? This is a record type. This record type has 3 labels called name, weight, and slots, and they are of type string, number, and number respectively. Let me create a few inventory items. I'm going to create a giant folder here. Appropriate. It'll be super good. It's going to take all your slides. And then let's create like sort. Typo is I didn't call the, this is actually a record, and this actually has type, this has this record type, but I don't want it to have that record type. I want it to be an inventory item. So I have to call the inventory item, inv item constructor on this record to get back a value of the inventory item type. And the sort, same way. Lightweight sort, actually it's a magical sort. We'll say that it actually allows you to carry them. But it's negatives. It's just pathetic. Okay, so that's record then. If I want to take this sort and update it, and I use the record update syntax, actually I'll have to do a function like this. I'll say make wait list. Define a function called make wait list here, which takes an inventory item and returns an inventory item. I'm not going to totally sketch it out for you, but you can finish it if you want. I'm going to say, I'm going to match against, actually there's just one case here. Actually, I'll just do R. I'm going to match against the record. I can do that. I don't have to match against fields in the record. I can give the whole record a name. Because records are a first class thing in PureScript. I can just give the whole record a name called R. And I can say, form a new inventory item by taking that record and updating the weight to 0. And then I would take my giant folder I'm going to make a wait list.
I'm sorry, when you did that construction earlier, you typed record, was that just a placeholder? Or did
Yeah,
that-
you can call that anything that you want.
Okay, thanks.
I tend to use very short variable names, and that's a habit you'll probably eventually fall into if you stick with a statically typed programming language like PureScript long enough. You'll eventually use shorter and shorter variable names because you'll start to learn to read the types and rely more on the types than on the names of the variables. Okay, so now I have this wonderful function that can make any inventory item weightless, and it can work with any record in its form. All right.
I'm sorry, just a quick question.
Yeah.
For weightless folder, do we not need to specify its type before declaring?
Yeah, PureScript will infer it. Again, I encourage you not to take advantage of that feature.
Okay.
Because it's working through the thing will teach you a lot about sort of how PureScript works and force you to be precise with things. But yeah, I don't actually have to do that. That's probably how you should do it for now until you're super comfortable with that. And then you can start omitting all these types. I can like totally delete all these types here. And PureScript will be, this is fine. And it looks sort of like JavaScript if you do that. But unlike JavaScript, the compiler will actually tell you when you get something wrong. Or at least a certain class of things wrong. Okay. So now we're going to go back to something that you've seen all along, and it's basic function types. Function types I introduced in almost the very first slide. And you introduced them using that arrow. Just that arrow, which looks just like the illustration of a function that I had up there at the beginning. And it basically says that fav is an element of the set of functions from monster to favorite food. See, I didn't talk about it that way before. Before I talked about it as fav is a function from monster to favorite food. That's true too. But another way to view this is that monster to favorite food is a type. And as we all know, types are sets. And therefore, what I've just described here, by writing this notation, monster, arrow, favorite food, is this set of all functions that map from monster to favorite food. And I'm saying that fav is actually a value. It's a value that is an element of the set of functions that map from monster to favorite food. So notice how subtle that is. That's an extremely subtle difference that you might not even pick up on unless you're paying extreme attention. But I've gone from describing fav as a function from monster to favorite food to being a value of a set of functions from monster to favorite food. And it seems simple, but if you can wrap your head around that concept that, yes, sets can't contain functions. They can contain all kinds of functions, crazy functions in there. Like I said, we're building upon the complexity of the things that sets can contain. And we're going to have to, very, very soon in the next slide or two, stop viewing fav as a function so much as a value of a set of functions. Does that make sense? Okay, so here it is. In fact, there is a way that you can define functions without sort of listing the elements in their domain on the left-hand side of the equal. Up till now, we've been doing things like fav of giant is humans, and fav of alien is kittens. And it's sort of like we list the name of the function and the element in the domain, and we say what element, what that maps to in the codomain, what the function maps it to in the codomain. And thinking about this more, thinking fav more as a value in the set of functions that map from monster to favorite food, there's actually a syntax that allows you to create a function as a value. And that's exactly equivalent to this definition of fav. That syntax is you use backslash, and the backslash is a poor man's lambda, hence LambdaConf. Lambda is just an inline function specified at the value level. That maps from monster, and then I use the arrow sign, and I'm going to list other stuff in here. Now,
How would I do this? Well, I'd have to use a case expression, that other way of pattern matching that I showed you early on. I'd have to say monster maps to case monster of giant banana. I have to match against those cases and define what the function was equal to in those cases. And of course, if you know JavaScript, you already know how to do this. In current version of JavaScript, you just do a var fave and then you assign it to this anonymous function. This anonymous function thing is actually a lambda, and it's a value. It is a function that is a value. And in ECMAScript 6, actually, the declaration looks much more like it looks in PureScript because you're able to read all this extra noise and just say monster maps to something. So let's create a function from monster's total hit points, express the same function as a lambda, and apply the function to various inputs. We're going to go super fast here because we need to pick up the pace to cover all the stuff I want to do. And we're going to express the same function as the lambda using that syntax that I just showed you. Remember, the other way of reading this hit points function, I'll call it hit points prime, is it's just a value. It's a value that happens to be a function. That is, it's a value whose type is the set of functions from monster to number. So if you picture a set here, and lots of functions being jammed into this set, and every function looks sort of the same. They all look like they accept the monster and they return a number. And this set, which contains all these functions, we're saying hit points prime is an element of that set. It's one of those functions that maps from monster to number. So we're just going to use equal sign. We're going to say m for monster. And I'm going to do a case m of werewolf maps to 10, vampire maps to 100, boom, done. And then we're able to call hit points as a value that happens to be a function. Call that on werewolf. We'll get that in. So the most important thing to remember from this lesson is that functions are just values. They're values that happen to be elements of a different set, a much more complicated set than any set that we've seen today. And those sets are about getting more complicated, but fundamentally every function is still a mapping from one set to another set. It's just the structure of things inside those sets can be simple, like we've seen before, or it can be complex, but fundamentally functional programming is all about mappings from one set to another. We're going to cover this briefly because it allows you to clean up some of your stuff. You've noticed that with a record type, actually even with a product type, I've had to repeat myself several times. Like for example, when I was talking about ogre and wolf, I decided to give them both names and locations and help. And that sort of repetition, and it gets old after a while. And one of the ways that you can reduce that boilerplate is you can give a name to a type. And so here I'm giving a name to this type called char data. It's just a type alias. There's a different name to refer to the type by. And every time the compiler sees a char data, it's going to look over on the right-hand side and say, what does that really mean? What's that an alias for? And here I've introduced a record type that has 3 fields called name, loc, and help. And now I can define ogre and wolf by saying, well, NPC is either an ogre that accepts char data, or it's a wolf that accepts char data, and char data is just a record, and those records happen to be the same, so I'm able to take out all that duplication that was there before and factor it out and make my code easier to understand and maintain. Now when I add a new type of thing to char data, I don't have to update the definition of NPC, it'll just be there. So it's good coding IP to use type aliases wherever you have
duplication at the level of types, i.e. sets. And then there's one more common thing that you're going to see in code that I'll cover briefly, and that's a new type. A new type, there's no difference, honestly, between a new type and a data. Well, there's two differences, but they're very minor. The differences are as follows. New type can only, your constructor for new type, health in this case, can only accept a single parameter. And the other difference is, using new types has zero runtime overhead. Why is that important? Well, it allows it to take something like a number and call that a health without sort of having the runtime overhead of boxing a number into a health data structure every single time. And so it encourages you to instead of passing around like number in your functions, to give those types like health and strength and stamina and stuff, which are really just numbers, right? But
So
this,
it's kind of like, say, alias, or?
it's not exactly an alias because new types actually do have a new type. That is, the compiler will treat them when it's compiling it down and checking for type errors and stuff. It's going to treat them as if they have a unique type. That is, a health is not a number. Those are two different sets, and I can't feed a health to something expecting a number, and I can't feed a number to something expecting a health. But at runtime, that is after the compiler has got done with beating me over the head with its stick, it's going to ultimately represent this at runtime with an ordinary number, and it's not going to have any additional runtime overhead. So you shouldn't be scared of using new types. And then that's where their limitation of accepting a single parameter comes from, because fundamentally, whatever parameter they accept, that's exactly how they're represented at runtime. So here I create, and I should have done this earlier, and I would have if we had had new types. I created a new type for health because I honestly don't want to just pass numbers around, and I can just create a new type called health and pass health around. That way, when you go to maintain the code that I wrote, you'll look at that and you'll say, oh, that's a health. That's not a random number. That's not strength. That's health.
Can you add two healths?
You cannot. You cannot add two healths because the addition operator expects two numbers, and new types are genuinely new types.
But new types apparently aren't as cool as we think.
No. That's a topic for a different class. Okay, so you can deconstruct them and you can pattern match on new types as if they were ordinary data. In fact, what I do when I'm factoring stuff is I start off with a new type, and if it ends up gaining more parameters than one, then it ends up evolving into data. But you don't really need to update your code. That is, you can take any new type and swap in data keyword there. Your code would work just fine, it would just be slow. Yeah.
Why is it called supports things like comparisons but doesn't support plus? I don't know why that would be.
So it actually does not support comparisons either, but that's an excellent question. What I'm doing in the isAlive function is I'm extracting out the value in the first slot from health, which happens to be a number. So I'm pattern matching on that health data constructor, and I'm extracting out the thing in its first slot, and I'm saying call that V, extract it out and call it V. And that's a number, and then I'm saying V is greater than 0.
Okay.
So I'm comparing a number against 0. But if I were to just say, isAlive V equals V is greater than 0, then the PureScript compiler would say, hey, I don't know what you're talking about here. Health doesn't have any such operator greater than defined. Okay, so let's quickly run through this exercise. We're going to create a record type. So we're going to use everything we've introduced today. We're going to create a type alias. It's just going to be a name. Remember, type aliases differ from new types, and that type aliases are just another name for a type, and new types actually are new types. We're going to create a name for a record called magical item rec, and it's going to have several fields. This is a magical item, so think like
one or something. And we're going to use the type alias to define a new type called magical item, whose constructor is called magical item. And we're going to create some values of this and maybe a few functions to extract out fields in that magical item. So what does this look like? Well, type alias, magical item rec. Maybe it can poison someone. So we're going to allow for that possibility. Maybe it can heal someone. And maybe it can damage someone. So type alias, or this record type here, means anytime I use this, PureScript compiler is going to say, oh, I know that's just an alias to refer to that type there. Now a new type called magical item is going to have a data constructor called magical item. It's going to accept one parameter, that's the limitation of new type, remember, which is magical item rec. And now I'm going to create one of these things. I'll say one is a magical item, and one I have to use. Remember, this is the same as a data constructor, except there's no runtime overhead, and I'm limited to the number of parameters I can have here. I have to use this constructor called magical item and feed it what it expects. What does it expect? Well, look at that type alias. It's just a record with 3 fields. So a 1 does not poison. A 1, let's say, heals. And a 1 can also do damage, serious damage. Yeah. And that's all there is to creating one of these things. And it's similar when I want to extract things out. I extract it just, I pattern match on it just like I would data. Let me just show you that. It's going to take a magical item and tell me how much poison it's going to do. Poison damage. So, magical item, and then my record is R. We'll just call it R. I can actually extract out the field that I want, but that's too cumbersome. I don't want to do that. I just want to do R dot poison. And there you go. I hope everyone does that. Who's following along anyway. Okay, higher kinded functions. Things are about to get real hairy real fast. And the key thing to keep in mind, remember, hold on to as tight as you can if you feel like you're getting lost, is everything's a function. Everything is a mapping from one set to another. Just hold on to that thought, no matter how complicated things get. Higher kinded functions. Well, I've already explained that sets can have functions, they can contain functions. Well, that means functions, which are mappings between sets, can map from sets of functions to sets of functions. Sort of a mind-blowing concept. If you grew up as a C programmer, like I did, it's sort of a mind-blowing concept when you run into that. It's like, it should be obvious, but if you've been programming a certain way for many, many years, decades, you lose sort of sight of what is intuitive and consistent anymore. And you find this concept truly mind-blowing. But fundamentally, sets are mappings between, or functions are mappings between sets. So your domain can itself be a set of functions. And your codomain can be sets of functions. You can actually have functions that map between sets of functions to sets of functions. Here's an example of a function that accepts a function. So this function accepts a function, which I call f in this example, and it's going to test that function. It's going to see if that function accepts a string and returns a boolean. So think of your domain as a set of all functions that accept a string and return a boolean. And how can we interpret this? Well, here's the intuition. The set of all functions that accept a string and return a boolean, that's sort of like saying, does that function like this string or not? Does it like it? Yeah, it returns true. Does it not like it? It returns false. So this is the set of all functions
that are able to render a value judgment on whether or not they like a given string. So what I do here is I give this function following type signature. It's going to accept the function, so I enclose this in parentheses, and I say this is a type, ordinary type. It's this type of, it's a set of functions that accept the string and return Boolean. And I'm going to say my function likes empty string picks one of those functions, and it returns a Boolean. And conceptually what this is saying is likes empty string is going to test, you can feed it any function. That is, you can feed it any element of the set of functions from string to Boolean. You can feed it any function at all that renders a value judgment on strings. And likes empty string is going to test that function on the empty string to see if that function likes the empty string. So how do I implement this? Well, it's pretty straightforward. I just call that function on the empty string right away, and I'm going to get back true or false. So if I want to test the function to see whether or not it likes or hates the empty string, I'm going to feed it to my likes empty string function, and I'm going to get back either true or false to see whether or not I like it. So this builds upon what we've learned so far, but it is possibly getting a little bit harder to understand here, because what I'm passing to likes empty string is not strings anymore, booleans or monsters or NPCs or magical items. I'm actually passing functions to it, and then it's returning a Boolean value. Well, what is it doing with those functions? Well, in this case, it's testing it against the empty string. So likes empty string doesn't break the pattern we've learned so far. It's a mapping from one set to another set. Its domain is the set of functions from string to Boolean. Codomain is Boolean, the set of Boolean values. Yes.
Is it significant that these are called higher kinded as opposed to higher order functions?
Sorry, it should be higher order functions.
Same thing? Or?
Similar.
Okay.
But I'll get into that in a second. It should be called higher order functions. Okay, so if a function's domain can be a set of functions, well, so also a function's codomain can be a set of functions. In other words, I can return a function from a function. And in this case, I create a function called matches that's going to take a string, and it's going to return a function that tells me if another string matches that string that I provide. Does that make sense? So, for example, I want a matcher, right? That is, I want a function that's going to tell me if a given string matches some pattern. And I want a matcher for the phrase evil. So I call my matches function with evil, and matches, the domain is a set of strings. So I'm going to feed in this evil string to my function, and it's going to take this and it's going to return another function that's going to tell me if a feed that I string it to matches evil. And so I create this matches evil function by passing in a string evil to this higher order function matches, which returns another function. So matches evil here is a function. Matches evil is a function that takes a string and returns a Boolean value. And then I test my function called matches evil against John of evil. With John, it returns false. With evil, it returns true. So this was a function that accepted a function and returned a value, an ordinary simple value. And this was a function that took an ordinary simple value and returned a function. And yes, you can combine them in arbitrary ways. And yes, as you start combining them, they do get harder to understand. And now, we can see how PureScript supports multi-parameter functions. So a function like damage NPC needs to take number of hit points, how much to damage the non-player character by. We're going to reduce his health by that specified amount. And it takes the NPC and it returns a new NPC with that NPC damaged by the specified number of hit points. So it takes two things, right? In JavaScript, we would say this function takes two things. It takes the hit points and the NPC and returns the NPC damaged by the hit points. We would say that in JavaScript. In PureScript, there are no such thing as multi-parameter functions. This is damage NPC is a function that returns a function.
And that generalizes to any number of parameters. In fact, if we have a big old long function called f, and you see that someone's feeding it A, B, C, D, E, well, you can think of that as being 1, 2, 3, 4, 5 parameters fed to the function f. But again, PureScript has no concept of multi-parameter functions. Everything is a function that is a mapping from one set to another. And how this happens to be is f of A into another function that you apply to B, which gets you another function that you apply to C, which gets you another function that you apply to D, which gets you another function that you apply to E, and then finally you get that value, which of course might be about function. And you're going to see type declarations that look like this. F in the preceding example has this type declaration. It says A, B, C, D, E, in that order, all separated by arrows. How do you interpret that? Well, if you want to think about it in multi-parameter terms, you can think about it as this function f takes an A, and a B, and a C, and a D, and returns an E. It takes 4 parameters and returns 1. But what that really is, and how you will think about that sometimes, is let's add parentheses everywhere the compiler adds parentheses, and we see that you feed f an A, and you get back another function. What is that function? Well, you feed it a B, and you get back another function. What is that function? Well, you feed it a C, you get back another function. You feed that a D, finally you get back an E. So there's only one concept of function in PureScript, and it's a mapping between domain and codomain. Just that the sorts of sets involved here can give you sets of functions. And these are all the different ways that you can write the function damage NPC using lambdas and or sort of pattern matching. And there are many, and you'll see them all from time to time. The different ways of writing this have certain pros and cons. So we are unfortunately out of time. I went a lot slower than I hoped to get through. But we have covered almost everything that you need to work on the example code. I went way slower than I thought. But we've covered almost everything. You can skip the stuff on higher kind of types for now. We've covered almost the stuff on polymorphism is important. I would spend a few minutes reading through that. All the materials online, so you can go ahead and finish up this workshop on your own. Parametric polymorphism is a very important concept. And if you've only done programming in something like Ruby or JavaScript, it's going to be totally foreign to you. So read that, check that out, and then download the code. The code actually requires that you implement a record that has this type signature here, that I've shown here. And here's what you have to do to implement a game. Everything else has been built around this. So your only job is to implement this function here, or implement a value of this type. It's a record. You have to specify the initial game state, and the game state can include anything you want. So you could put a map in there, you could put some characters in there, whatever you like. You have to be able to describe the game state, so you have to be able to turn that game state into a string that the user will see. And you have to be able to parse an input. Actually, I did that part for you. If you want, you don't have to do that. And finally, you have to be able to give them an input from the user, like maybe they want to quit, or they want to move north, or they want to drop something, or pick up something. You have to be able to translate that into either an error message saying, I don't know how to handle that, or into a new value for that game state. So the core of this game loop is essentially a function from game state to new game state given some input. And if you implement that function, it's already implemented, but you add stuff to it. You can actually build a fairly interesting game without too much work. And that's pure. There's no effects there. Everything's a pure function. So thank you for attending my workshop. I'm sorry we didn't get through all the material. Good luck finishing it on your own. And please do let me know if I owe you a copy or not, because I will make good on that promise. Thank you very much.